So as you see here, I have a couple 2-liter bottles. I'll see if I can show this here. On the bottle here, I'm not sure it's showing it. There's a tiny little triangle there with a 1 inside of it, and underneath of it says PETE. And that's a certain kind of safe, I think it's a one-time use plastic bottle, and it doesn't filter out the UV rays, and that's why it's good for this sort of thing where I'm going to try to use the sun's UV rays to to distill rainwater that I happen to collect already. Now what we'll do is go over here and collect some of this rainwater, put it in these bottles, and then I'll use this tape, connect the 2 bottles. What's going to end up happening is the 2 bottles will be taped like this. Now one bottle is going to be full, not full. One bottle is going to be partly filled with rainwater, and the other one's going to be empty. Now the idea is when you set it out in the sun's going to heat up the water and create steam, condensation. And the condensation is going to move from the filled bottle to the empty bottle. Now through the distillation process, that water should be clean. Now I'm going to use a TDS meter, which TDS stands for total dissolved solids. Now that's covering things like heavy metals and a couple different chemicals that might be found in water. It doesn't test for pathogens and viruses or bacteria, any of that sort of thing that might be in the water. But through the distillation process, all that stuff should be removed. So that's why I'm doing this. That's why I believe it's going to work for me. And again, do your own research, and the due diligence falls on you if you decide to do something like this as well. Alright, here's my rain catchment. Now, this isn't a permanent setup. Gutter absolutely should not be in the water. I threw this up the other day just because I knew it was raining, or gonna rain. I had these barrels that I haven't got to properly set it up yet, so don't do that. Which the idea is you want the rain water to come in here. You want to put some sort of, these eggs are even going to be hard boiled, or lid or some sort of cover over top of this, so you don't get mosquitoes or any kind of bug in there, and another kind of bacteria or any kind of thing like that falling inside there. Real easy. But whereas one that still has a yolk, a runny yolk, it wobbles. I'll show you here. So we'll see if this wobbles. I tested this the other day. It's warm to the touch. Yesterday when well, I don't feel the yolk. I don't feel the yolk in there. And we'll get a general idea of the TDS of this water at this moment. Yesterday, it might be partly cooked. It was at 009. So we'll see where it's at now. See how it's not spinning? No, it's on hold. That's why. Yeah, I don't think that's going to be safe to eat. It's at 010. I didn't just waste 4 eggs. So 10 parts per million. I don't know if I can. Which is considerably clean as far as total dissolvable solids. At this point, the sun's going down. That being like heavy metals. Definitely on the other side of the house. Fluoride dropping significantly. Chlorine and stuff like that. No way add to the water. Use the sun. Now, obviously, distillation, this being rainwater or hard boiling eggs. A lot of those chemicals that's added. So I have to come up with city water isn't added to the rainwater. It's not in this rainwater. Now, city water,
I don't really have a pot.
The TDS is right around 280 parts per million.
I can
now parts per million, or TDS doesn't tell you exactly what is in the water.
Fire.
It just measures what.
Just toss the eggs in there in the foil.
Right. So you can get a water analysis. Figure out exactly what is in the water, and you'll have a better idea
once you clean these
what
eggs
you're dealing with. But
and you don't
10 parts per million,
you have a certain period of time until bacteria starts to form and
bottled
starts to go bad
water that I drink
inside.
Dasani bottled water,
Now,
and it's at 25 parts per million.
I don't know the perfect science to
which
that.
Is significantly better.
So
than
I don't know if these eggs
city
are good
water
or not. And I don't know if I'm cooking them now.
And this is potentially even better
if it worked
than
them in the
bottled water
inside the foil,
purified already.
Still might not be safe to eat. So I don't know if this is something.
Just little information about how
when somebody else
rainwater works is you get there's 3 processes. You have the evaporation, you have condensation, and then precipitation.
You learn doing this.
Evaporation
types of
as the water goes up into the sky from the
just like that
from the sun. Condensation is when it builds up and forms a cloud. Tiny rain droplets form a cloud, and then precipitation is the obvious rain. Now, that's the exact process of what distillation is, so it's just on a very grand scale. So it kind of makes sense that this water would come out exceptionally clean when you start with rainwater. And that's why I'm going to start with rainwater here, because for the most part, it's pretty damn clean. You can't get much cleaner than that unless you actually filter the water or distill the water in that sort of way. All right. So what I'm going to do here, as you can see, there's some floaties in there. Because I don't have a lid for it, I definitely should. So, again, don't do what I do. This is just for educational purposes only. Do your own due diligence. Make sure you know what you're doing. And don't do it because I did it. Don't do it because I said so. I'm not saying so. This is just what I would do for myself, for my loved ones, for my family, if I had to procure my own water. Now, the bottle's going to be sitting on its side, so you can't fill it up. Yeah, you can't see it the way I'm holding it. You can't fill it up past the neck of the bottle here, or it's going to just automatically go into the other bottle and contaminate everything. Now, you don't want that to happen. You contaminate it, then you're liable to get some sort of pathogen. It's going to end up you in the hospital and potentially putting your life at risk. You drink bad water one time, you might die from it. So make sure you know what you're doing before you do this sort of thing. But yeah, so that's probably, it's just a tiny bit under the neck when it's sitting flat, so I'm going to leave it at that. And I'll fill the other one up about the same. I'm going to try to do 2 of these because, as you see, that's not a whole lot of water. And not all that water is going to distill. So I'm probably only going to get a cup or 2 of water per bottle. This is probably going to take a few hours just to get a cup of water, or maybe a few cups of water. So again, this is why I'm starting with this first, because it's priority number 1 as far as I'm concerned, right behind oxygen, which, again, like I said, we all take that for granted, and if we had to come up with our own oxygen, probably not going to make it. So I'm going to fill up this other bottle. I might have went over too much on that one. What I'm going to do first because these bottles are obviously contaminated at the top here. I'm going to set them out in the sun for a little while and let them dry. And hopefully that'll sterilize them at least a little bit here. I'll be right back with you. Alright, I taped these up a lot better now, and I believe the transfer rate's going to be a lot better. Yeah, they should do a lot better. I can already see tiny little droplets forming in the other bottles. So this might be quicker than I realized. I've never actually did this. There's other ways to distill water, but without having, gas or charcoal on hand, which charcoal a lot of people have on hand, and I do. But if you don't happen to have charcoal, and you probably do have clear plastic bottles, then all you really need is some sort of water source and the sun. And I think that's more convenient for everybody. It's something that a lot more people could replicate if they so chose to do so. Again, don't take my advice. I'm not a professional. It's just what I would do for myself, for my loved ones, for my family, that sort of thing. Do your own due diligence and make sure you know what you're doing, and it's on you. It's your own. You're liable. You know what I mean? Yeah. So I was taking a look here at the attempt at distilling water, and you see the one side where the rainwater was or is beaded up quite a bit, and the other bottles have much tinier droplets. But I don't believe that there's a really successful transfer rate. There's maybe there's next to nothing in these bottles, and I think what the issue was I didn't tape this really good. I think this connection between the two bottles basically needs to be airtight, because right now what's going on is the water vapor is basically just evaporating out of the bottle instead of transferring to the other bottle. So this was one of those scenarios where this was my one and only source of water. This would be a fail. And that's something good to know, because I might have thought that this was a reliable way for me to produce clean, potable water. Now, I know this works because I've seen other people do it. So this is just something that I've made a mistake on. And this is the type of thing that is important to learn, and why doing these test scenarios is a good thing, because in practicality, I don't know the correct way to do it, or I already would have, and so I'm learning here. This is the whole idea, the whole reason for doing this is learn what you do know and learn what you don't know. Now tomorrow, I should have a better idea, come up with a better plan, and that's all I can do. Just take one day at a time and improve. But sometimes you win, sometimes you lose. Now, if it comes down to water, you got to win in about 3 days, or you might die, because you need water in roughly 3 days, or you might die. That's the rule of 3. So that's the type of thing that you learn when you do this sort of experiment.